check. All right, people. I believe everybody is doing great, nice, and absolutely fine. Please let me know in the chats if I'm perfectly audible, visible to each and every single student. Let the people join and we are starting the session. Okay. So, what's up, people? I believe all of you are doing great, having the good time. Okay. In the today's session, we will be basically focusing on 3 chapters. Electromagnetic induction, you have alternating current, okay, and you have electromagnetic waves. If you are learning for the first time, when it comes to this chapter, if you are learning for the first time, you would be able to understand each and every single thing. That is my promise. You will understand each and every single thing. That is my promise. Okay. So, my dear NEET aspirants, let's, and session duration is going to be 2 to 3 hours. 2 to 3 hours. So, we will try to cover the complete, all these chapters in this one in 2 to 3 hours. Okay. It will be to the point, from the scratch. So I would want you guys to give me 100% of your attention. Okay. And do smash the like button, because I would want you guys to smash the like button and mark your attendance, because marking the attendance is mandatory. Okay. So my dear NEET aspirants, let's basically start with electromagnetic induction. Electromagnetic induction. What is the first topic that we need to start with in this electromagnetic induction? Listen to me very carefully. Listen to me very carefully. I will make you understand what electromagnetic induction is. So the first topic in the electromagnetic induction is basically magnetic flux. Okay. So the first topic is magnetic flux. Listen to me very carefully. What does magnetic flux actually mean? Let's suppose, my dear NEET aspirants, you place a magnet over here. You place a bar magnet over here. Because of the bar magnet, we say magnetic field will be there. Yes, sir. So we represent that magnetic field with the help of these magnetic field lines. Okay. We represent that magnetic field with the help of these magnetic field lines. And we represent magnetic field with B. So basically, this is the region in which magnetic field is present. Where does this magnetic field come from? Maybe I have placed a bar magnet over here. Because of that bar magnet, these field lines are coming out. So this is the field due to the bar magnet in this region. And I am placing a sheet. Over here. Let's suppose I am placing this sheet. This sheet. So basically, these are the field lines which are coming out. I am placing the sheet in front of the magnetic field lines. Okay. Let's place one more sheet. This is one more sheet. Now, could you please tell me, in this particular case, how many field lines are crossing through the sheet? 1, 2, and 3. So I can say flux through this sheet will be, that is 3. How many field lines are crossing through this sheet? 1, 2, 3, 4, 5, 6. So I can say flux through this sheet is 6. So can I define magnetic flux as, it is the number of magnetic field lines crossing the surface perpendicularly? Absolutely, sir. How many number of field lines are crossing the surface perpendicularly? That is what we call the magnetic flux. Okay. And how do we define this magnetic flux? See, guys. So we said this magnetic flux is simply magnetic field into area B dot A. See, more is the magnetic field, more field lines will come out. More field lines is going to cross, we say, this surface. More will be flux. More is the area. You see, area of the second sheet is large. You see, area of the second sheet is large. Okay. You see, area of the second sheet is large. So magnetic flux through the second sheet is large. So flux is directly proportional to magnetic field. Flux is directly proportional to area. Even you can write this something like this. B dot A is BA cos theta. BA cos theta. This is the magnetic flux. This is the magnetic flux. BA cos theta. Now, my dear NEET aspirants, what I want you guys to do over here is, let's suppose we have a question over here. Question is this one. There is a ring placed over here. In this ring, current is flowing. Current I is flowing in the ring. Current I is flowing in the ring. Okay. Absolutely, sir. Now there is a square loop which is placed at the center. A square loop is placed at the center. This is the square loop which is placed at the center. Okay. And length of this square loop is L. I am asking you, current I is flowing through the ring. Through this ring, current I is flowing. Find the magnetic flux through the square loop placed at the center. You guys are supposed to tell me what is the magnetic flux through the square loop. Sir, magnetic flux will be only created when number of magnetic field lines cross the surface. Is there any field line crossing the surface? Yes. Let me tell you why. Whenever current flows through a ring, whenever current flows in a wire, it creates magnetic field. So this ring is going to create the magnetic field. How do you find the direction of that magnetic field? See guys, curl your fingers along the direction of current. Curl your fingers along direction of current. Thumb is pointing up outwards. So means magnetic field through this is outwards. So outward means dot. So magnetic field, it is like this. This is a square. So magnetic field is crossing this square. So magnetic flux will be created. Now tell me, how do you find that flux? That flux will be magnetic field into area and then we say cos of theta. Now guys, see, magnetic field here is created because of this ring. Now, if you ask me what is the magnetic field due to a ring at its center, that is mu naught I divided by 2r. This is the magnetic field due to a ring at its center, mu naught I by 2r. Now, this magnetic field is outward and it is crossing the square loop. What is the area of square loop? Area of square loop is side square, that is L square because its length is L. And what is the angle? Always remember, my dear NEET aspirants, if this is area, direction of area is always perpendicular to the surface. If this is surface, what is the direction of area of the board? Perpendicular to the surface. So what will be the angle between? What will be the angle between? Magnetic field is also out. Area vector is also out. What is the angle between magnetic field and area? 0 degrees. So I can write over here, this magnetic flux is, magnetic field is mu naught I divided by 2r. And instead of this area, I can write L square and cos of 0. Cos 0 is, by the way, 1. So basically, this will be mu naught I into L square divided by 2r. This will be the magnetic flux. This will be the magnetic flux created through the ring. And in this particular case, we say L is much, much less than R. Means the length of this ring. Imagine this is a very small square loop placed at the center. Placed at the center. Okay. Now find the flux through the ring. Now we are placing the ring at the center. Let me redraw it actually. Now in this particular case, we are placing the ring at the center. Okay. We are placing the ring at the center. And this ring has got radius R. Now guys, current is flowing in the square loop. Right now, we say square loop is going to create the magnetic field. And that will cross the circular loop. So I say, what is the magnetic field due to the square loop? Square loop. Guys, directly remember, magnetic field due to a square loop at its center is, that is 2 root 2 mu naught I divided by pi into L. 2 root 2 mu naught I divided by pi into L. This, see. This is a condition over here. You said this is the magnetic field at the center. This is the magnetic field due to a ring at the center. So if you are assuming the magnetic field at the center, then you have to assume this at the center. You have to assume the size of the square loop is very small. You have to assume it is exactly at the center. Then only you can say this is the magnetic field. This is not the magnetic field here, 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 here. This magnetic field is at the center. That's why in this case condition is given as L is much, much less than R. Means this is very small. It looks like it is at the center only. This is the point. This is the point. Now this is the magnetic field due to the square loop. Right now current is flowing through the square loop. So it will create the magnetic field at the center. So what is the area of the square loop? Now this magnetic field will cross this loop. Magnetic field due to this square loop is going to cross the circular loop. So I can say what is the area of circular loop? That is pi r square. Now tell me what is going to be the flux. Flux is magnetic field into area. So that is B into A. So you can say flux will be, what is magnetic field in this case? That is 2 root 2 mu naught I divided by pi into L. And area is simply that is pi r square. Pi r square. It is capital R. So pi into capital R square. Now could you please tell me, can I cancel it? Cancel something? Pi and pi will be cancelled. So flux will come out to be, that is 2 root 2 mu naught I into R square divided by L. This is the flux at the center. Guys, please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. Quick. Quick. Tell me, guys. And do smash the like button because liking the session is mandatory. Let me know in the chats if this is crystalline clear. Let me know in the chats if this is crystalline clear. Okay. Let's move on to the Lenz law. Let's move on to the Lenz law. See guys, I will make you understand what this Lenz law is. Let's suppose my dear NEET aspirants, I want you guys to focus over here. Let's suppose we have a ring over here. This is a circular loop. This is a circular loop. And you place a magnet over here. You place a magnet over here. Okay. Yes. You place a magnet over here. I'm saying that because of this bar magnet, magnetic field lines will come out. Magnetic field lines will come out. Something like this. Okay. Magnetic field lines will come out. Now, if I say that you take this bar magnet close to this loop, could you please tell me, will more number of field lines cross the loop if you are taking this magnet close to the loop? Could you please tell me in that particular case, how many number of field lines will cross through the loop? Sir, will that be more or less? Sir, if you take this magnet close to the loop, I can see that more number of field lines are crossing the loop. If you take this magnet away from the loop, we say less number of field lines are crossing the loop. Some may go something like this, something like this. So basically, whenever we take a magnet close to the loop, listen to me very carefully. Lenz law, I'll make you understand. Whenever you take a magnet close to the loop, we say magnetic field lines through the loop will change. Magnetic field lines through the loop will change. Even magnetic field lines through the loop will increase. When you take the magnet away from the loop, magnetic field lines will decrease. Okay. So when you are taking this magnet close to the loop or away from the loop, magnetic field is going to change. Okay. When magnet is taken close or away from the loop, in that particular case, my dear NEET aspirants, I can say then I can say magnetic field is going to change. Magnetic field will change. So magnetic field through the loop will increase or decrease. If magnetic field changes, I can say because of that flux changes. Because of that flux changes. And my dear NEET aspirants, whenever flux through the loop changes, we observed that experimentally we are doing this. When we change the flux through the loop, when we change magnetic field through the loop, we saw current is produced. Current is produced or induced. So current started flowing in this loop. Now, if you ask me what is the direction of that current, direction of that current is given by the Lenz law. Direction of that current is given by what? Lenz law. So, direction of that current is given by Lenz law. Let me just tell you how is going to be the direction of that current. And I'll write direction of that current. That current is given by Lenz law. Direction of that current is given by Lenz law. Now, my dear NEET aspirants, could you please tell me how that direction is going to be? Listen to me very carefully. What does actually Lenz law say? What does actually Lenz law say? Now see what is mentioned over here. Due to the change in magnetic field through the coil, whenever you change the magnetic field through the coil, current starts flowing through the coil. Now, what should be the direction of that current? This direction is given by Lenz law. See what does Lenz law say? If the magnetic field through the coil increases, current will oppose the magnetic field. Let me just write over here. Direction of that is given by Lenz law. If the magnetic field through the coil increases, the current produced in the coil, this is I is current, will oppose it. This current will oppose it. And my dear NEET aspirants, if the magnetic field through the coil decreases, this current will support it. This is what we call the Lenz law. Now, let me show you the question. From the question, you would be able to understand how is going to be the direction of the current. Listen to me very carefully. Lenz law says that if primary magnetic field through the coil increases, current will oppose it. If primary magnetic field increases, current will oppose it. If primary magnetic field decreases, current will support it. Are you getting me, my dear NEET aspirants? Are you getting me? Are you getting me what I'm trying to say in this particular case? Current will support it. Now listen to me very carefully, my dear NEET aspirants. Let's suppose you have placed this circular, let me place a circular loop over here. Circular loop is going to give you the more field. Let me place a circular loop in this magnetic field. And this magnetic field is dot. Dot means outward. This is outward magnetic field. Dot means what? Outward magnetic field. And this outward magnetic field is increasing. It is like this. Listen carefully. This is a ring. And through this ring, magnetic field is coming out. And this magnetic field is increasing. Listen, please. I'll show you one question. With one question, you would be able to understand. So I can say in this particular case, B primary. This means B primary. It is increasing. Okay. Now, my dear NEET aspirants, and it is outward. Now, Lenz law says that if primary magnetic field is increasing, current will flow in the coil. First of all, will the current flow in the coil? Yes. Why? Because magnetic field is changing. So the direction of the current will be in such a way so that it will oppose it. How it is going to oppose? Listen to me very carefully. Let's suppose if I say magnetic field primary is towards the right. If you have to oppose this, you have to apply the magnetic field in the opposite direction. Yes, sir, that is the opposition. If I say you have to support it, apply the magnetic field in the same direction, that is what we call the support. Now take a look here. Take a look here. Your magnetic field is increasing, primary. Now, if you have to oppose this increasing magnetic field, which is outward, you have to oppose it by applying one more magnetic field. And that magnetic field must be, if this is outward, that must be inwards. That must be inwards. Now listen to me very carefully. Guys. Because of this magnetic field, current will be flowing in this one. And in this case, I would say current in the coil will be clockwise. Sir, why did you say current in the coil will be clockwise? I will tell you. We say current induced in the coil is clockwise. It is clockwise. When you create a clockwise current, now listen to me very carefully. Sir, we have studied this also. If you have not studied, then learn right now. Whenever current flows through the coil, whenever current flows in the coil, it produces the magnetic field. So here current is flowing in the coil. So it is going to produce the magnetic field. And that is what we call the secondary magnetic field. And the direction of that secondary magnetic field will be, curl your fingers along the direction of current. Thumb is pointing inwards. So due to this current, one more magnetic field is being produced, that is secondary magnetic field. Now you see, B secondary in this particular case is inwards. That is what we wanted actually. See, what is the case? What I am trying to say in this particular case is, because of this primary magnetic field, when you change it, current is flowing in the coil. When current starts flowing in the coil, because of that, secondary magnetic field will be created. Okay. Because of that, secondary magnetic field will be created. Let's suppose due to this changing magnetic field, this is the current produced in the coil. Something like this. Okay. Something like this. Anti-clockwise. Now, because of this current, one more magnetic field is being produced. That is B secondary. This secondary magnetic field is opposing this primary magnetic field. So that is what the Lenz law is saying. Lenz law said, if the primary magnetic field is increasing, you make the direction of current such a way so that it creates one more magnetic field which opposes that primary magnetic field. Let me show you one more question. Let's suppose if I say, listen carefully. Let's suppose if I say, you have got a magnetic field, this is inwards. In this inward magnetic field, you place a loop. And this inward magnetic field, this is B primary, it is decreasing. Now tell me, if the primary magnetic field is decreasing, okay, and it is inwards, now you guys tell me one thing, current will flow in the coil? Yes. How should the current flow? What should be the direction of the current? Sir, make the direction of the current in such a way so that it supports the primary magnetic field, so that it supports the decreasing magnetic field. So I'll make it in this direction, clockwise again. So I say current has to be clockwise in this particular case. Why? Because then only it should create the secondary magnetic field. Due to this, one more magnetic field is being created. Curl your fingers along direction of current, thumb is pointing inwards. So in this particular case, B secondary is inwards. So B secondary in this particular case is inwards. Now see, primary magnetic field is decreasing and is inwards. You have to support the decreasing magnetic field, so you are applying the secondary magnetic field in the inward direction. Guys, tell me in the chats if this is crystal and clear. Let's suppose you are supposed to find what is the direction of the current in this particular case. Guys, see, this is a wire. In this wire, current is flowing. Now, because of this wire, magnetic field is being created over here. Now, see, place your thumb along direction of current. Curl your fingers. So, when you curl your fingers, so because of this wire, because of this current, magnetic field at this point will be outwards. Magnetic field at this point will be outwards. This is primary magnetic field. This primary magnetic field is because of this primary current. If the current is increasing, magnetic field created due to this will be increasing. So B primary is increasing. Okay, and it is outwards. If B primary is increasing and is outwards, now tell me, if the primary magnetic field is increasing, secondary magnetic field should oppose it. So means secondary magnetic field has to be inwards. Okay, because if this is outwards increasing, so secondary magnetic field has to be inward. So that is only possible if you make the secondary magnetic field inward. That is only possible if the direction of the current in this case is, I would say, clockwise. So curl your fingers along direction of current, thumb is pointing inwards. So because of this current, one more magnetic field is being produced which is inwards. Guys, tell me in the chats if this is clear. Tell me and smash the like button. Huh? Tell me in the chats if this is clear. Let's suppose you have this question. Current is flowing in this direction. This is primary current. Now, because of this current, you have to find the current, direction of current here, direction of current here. Place your thumb along direction of current, curl your fingers. So basically, due to this, magnetic field will be inwards from this side. This will be primary magnetic field. So for coil A, I can say B primary, and if this current is increasing, because of this magnetic field which is being created, that will be also increasing. This is also increasing. And it is inwards. Now you tell me one thing. If this is inwards, cross means inwards, dot means outwards. If this is inwards, how did you find the direction inwards? Place your thumb. Magnetic field created because of this wire, straight wire. Place your thumb along the direction of current, curl your fingers. So this is how we find the direction of the current because of the straight wire. That is inwards. Okay, so B secondary in this particular has to be outwards. So how is it possible that B secondary in this particular case is outwards? Outward means dot. When the direction of the current is anti-clockwise. When the direction of the current is anti-clockwise. I is ACW. Let's find the direction of the current in the coil B. Let's find the direction of the current in the coil B. How do you find the direction of the current in the coil B? Guys, see. The direction of magnetic field in the coil B. Place your thumb along the direction of current. Curl your fingers. So magnetic field, because of this wire from this lower side, it is outwards. This is B primary, outwards. Dot means outwards. So for coil B, I would say primary magnetic field is increasing and it is outwards. Now, if primary magnetic field is increasing and is outwards, you tell me, my dear friends, one thing. Secondary magnetic field has to be inwards. B secondary has to be inwards. Why? Because primary is increasing. So how is that possible? How is that possible? When the direction of the current is clockwise. So if you say B secondary has to be inwards, that is only possible when you keep the direction of the current in the clockwise direction. So we say current has to be clockwise in this particular case. Please tell me in the chats if this is crystalline clear. Tell me if this is crystalline clear. Tell me if this is crystalline clear. Come on, tell me. Is this clear? Oh? Quick. Is this clear? Now take a look. This is a circular loop which is moving in the constant. This is a uniform magnetic field. Magnetic field is uniform. It is moving in a uniform magnetic field. So when this circular loop moves in a uniform magnetic field, okay, when this circular loop moves in a uniform magnetic field, my dear NEET aspirants, what will be the current at point A? I would say current at point A is 0. No current will flow through the loop. Why? Because no magnetic field is crossing the loop. Magnetic current is only being produced in the loop when magnetic field through the loop changes. There is no magnetic field outside of this region. If there is no magnetic field present outside of this region, can we expect that the current should flow in the loop? No. While the loop is going in, as loop keeps on going inside the region, we say magnetic field increases. Here magnetic field increases, B increases. And if magnetic field at this point increases, listen to me very carefully, and is inwards. Okay. So what I can say in this particular case, my dear NEET aspirants, as it keeps on going in, more field lines will cross. So magnetic field is increasing, it is inwards. So what I can say in this particular case, I would say B secondary, this is B primary, B secondary in this particular case must be outwards. Because primary magnetic field is increasing. And this B secondary is being produced by the current which was induced by primary magnetic field. So due to this primary magnetic field, current is induced, and that current will be anticlockwise. Now, because of this anticlockwise current, I would say secondary magnetic field will be outwards. So current here is anticlockwise. Now, when the loop is inside the magnetic field, inside the region, we say constant number of magnetic field lines will cross through this. Because magnetic field from this point to this point is uniform. It is moving in the uniform magnetic field, means magnetic field through the loop will remain the same. So if magnetic field through the loop is constant, so we say in that particular case current will be 0. Why? Because current is only being produced in the loop when there is change in magnetic field. If magnetic field does not change, we say there will be no current produced in the loop. While it is coming out, my dear NEET aspirants, we say magnetic field lines through the loop will decrease. So I would say primary magnetic field will decrease. And it is inwards, You can see it is inwards. So can I say in this particular case, sir, this will create the secondary, this will create the induced current? Yes. What will be the direction of that current? The direction of that current will be clockwise. Why? Because if you keep the direction of the current as clockwise in this particular case, then only it will create the secondary magnetic field which will support the decreasing magnetic field. So secondary magnetic field also has to be inwards. Why? Because primary magnetic field is decreasing and is inwards. Secondary has to be inwards. So that is only possible if you keep the secondary magnetic field, if you keep the current in the clockwise direction. Okay. Tell me, is this clear? Tell me, is this clear? Yes. One more question I just want to say. One more question I just want to explain over here. You have got a loop that is it. This is the coil A, this is the coil B, and this is the magnet. This is the magnet. Listen to me very carefully. Whatever I say in this particular question, please do remember this directly. Don't ask me the questions why and how, because now is not the time. If I say find the direction of the current in the coil, in both the coils, coil A and coil B, with respect to the observer. If you ever face a question of this sort with respect to the observer, let me tell you what you guys are supposed to do. Listen carefully. This magnet is basically moving towards the coil. Always remember, this coil will never want magnetic field through it should increase. If the magnetic field is moving through the coil, we say more number of field lines will cross. So, but the coil is not interested in that. Coil never wants that the magnetic field through it should increase. So it will oppose this primary magnet. So it will create an imaginary secondary magnet. it will create an imaginary secondary magnet. This is what we call the south pole of the bar magnet. This is called north pole. So if this coil has to oppose the primary magnetic field, or this coil has to oppose the increasing magnetic field, that's what Lenz law say. Oppose the increasing magnetic field and support the decreasing magnetic field. It will create an imaginary bar magnet inside. That imaginary bar magnet will be having the north pole from this side, south pole from this side. Why? Because north like poles repel, like poles repel. And this bar magnet moves away from this coil. This bar magnet moves away from this coil. A coil never wants that the magnetic field through it should decrease. Neither it wants the magnetic field through it should increase, nor it wants the magnetic field through the coil should decrease. Here it is increasing through this coil. So that's why it is opposing. Here it is decreasing because it is moving away from the coil. So it will support. So it will create south pole from this side and it will create, it will create north pole from the side and it will create south pole from the side, because north pole will attract the south pole. North pole will attract the south pole. Okay. Oh, I'll send you. Part 1 PDF I'll send you. Chill, take a chill pill. Okay. So my dear NEET aspirants, first of all, you need to do this. Now see, how do you draw the direction of the current? If the observer sees north pole in the coil, see, observer is facing the north pole in this coil, then current you consider anti-clockwise. In this particular case, current will be ACW, anti-clockwise. And if the observer sees south pole in the coil, if the observer faces south pole of the imaginary bar magnet, in that particular case, current will be clockwise. Okay. Now guys, let me give you one more question on this one. Let's suppose you have got a coil. Over here. This is a coil. And this is one more coil. Let's place the observer over here. This is observer. Okay. And in this particular case, this is the bar magnet which is moving towards this. This is north pole and this is south pole. Now you tell me, the coil will repel the bar magnet if it is moving towards the coil, and the coil will attract the bar magnet if it is moving away from the coil. So it will repel here and it will attract here by creating an imaginary bar magnet. So if this is north pole, this will be north pole, and from this side it is south pole. And it is this bar magnet is moving away from the magnet. So it will create the north pole from this side, south pole from this side. Now tell me, what is the direction of the current? Observer is facing in this particular case what? South pole. Observer is facing south pole. So current in this particular case is clockwise. Observer is facing north pole. Current in this case is anti-clockwise. I believe this is crystalline clear. Faraday's law of electromagnetic induction. No, I'll upload it today. I'll upload part 1 class, which part 1 class 12th, huh? I'll put up in the Telegram channel, okay? Faraday's law of electromagnetic induction. Take a look, guys. Let's suppose you have a coil over here. Okay? And my dear NEET aspirants, I'm saying that through this coil, magnetic field changes. We say through this coil, magnetic field changes. Okay? When magnetic field through the coil changes, means by taking magnet close to the coil, away from the coil, we say flux changes. When flux changes, we say current is induced. And when current is induced, my dear NEET aspirants, according to the Ohm's law, we say V is directly proportional to I. Means current will be in a conductor only when there is potential difference. Sir, if there is no potential difference, will there be current? No. So means potential difference means EMF, or you say potential difference. So means whenever there is current, if I say current in this particular case, in this pen is flowing, means there is potential difference. Without potential difference, current cannot flow. So means in this particular case, if current is induced, means EMF is induced. Because without EMF, current is not possible. That's why we say EMF is induced. EMF means potential difference. EMF means potential difference. So, because of changing magnetic field, flux changes. When flux changes, we say current is induced. When current is induced, we say EMF is induced. EMF is there. Now, can I not directly say, my dear NEET aspirants? So, by changing the magnetic flux through the coil, we say EMF is induced. So, write this mathematically. So, I can say, sir, this EMF will be rate of change of magnetic flux through the coil. That is, I can say d phi divided by dt. d phi by dt means change in flux with respect to time. When flux changes with respect to time, it is going to give you the EMF. That is how we define the Faraday's law of electromagnetic induction. This is the Faraday's law. Whenever flux through the coil changes, means magnetic field through the coil is changing, we say EMF is being induced. EMF means potential difference. And this negative sign is because of the Lenz law. If primary magnetic field increases, you have to oppose it. If primary magnetic field decreases, you have to support it. Okay, this is EMF. Now, my dear NEET aspirants, this EMF, this potential difference is being induced in this one. If I say what is going to be the average EMF? Sir, EMF average, you will simply say EMF average will be minus delta phi divided by delta t. Minus delta phi divided by delta t. Minus delta phi divided by delta t. Sir, what is this delta phi? Delta phi means total change in flux upon total change in time. Let me just give you an example. Let's suppose this is the coil over here. My dear NEET aspirants, this is the coil. If I say in this coil, magnetic flux keeps on changing from 9 a.m. to 1 p.m. How much is the flux being produced? How much is the EMF being induced from 9 a.m. to 1 p.m.? That is the average EMF. Now, if I say how much EMF was produced when the time was exactly 10:30, that is called instantaneous EMF. EMF created in a coil at a particular instant, that is instantaneous. EMF created from this time to this time, that is average EMF. So can I say instantaneous EMF, we can write over here, that will be minus d phi by dt. This is how we write instantaneous. D phi by dt, and this is average. Okay. Okay, one more important thing, my dear NEET aspirants. Can I say when EMF is there, current is there? How do we find the current? Guys, you might have heard I is equal to V divided by R. R is the resistance. V means EMF. EMF divided by R. Now tell me, what is going to be the average current? You say, sir, average current in this particular case will be simply, that is EMF average. EMF average divided by resistance R. What will be the average EMF? Guys, average EMF will be minus delta phi divided by delta t into, I would say, R. This will be the average current. If I say, my dear NEET aspirants, what will be the instantaneous current? That is going to be minus, instantaneous current will be EMF instantaneous divided by R. What is the instantaneous EMF? That is minus d phi divided by dt into, I would say, R. Okay, ignore the negative sign, just only mention the magnitude of the current. This is going to be the current. Okay, even you can find the charge flown whenever the current flows through the coil. Okay, whenever current flows through the coil, it means charge is flowing. So can I write, guys, can I write this current as, what is the current means rate of flow of charge, that is delta Q by delta T. It will be from this side, delta phi divided by R delta T. So delta T and delta T will cancel. So delta Q will come out to be delta phi divided by R. This is what we call the Faraday's law of electromagnetic induction. Whenever flux through the coil changes, EMF is induced. Faraday's law. Okay. It states that the magnitude of induced EMF in a circuit is equal to the rate of change of magnetic flux through the circuit. EMF is equal to minus d phi by dt. Okay, instantaneous EMF will be, okay, it's saying magnitude, so d phi by dt, this is average is delta phi by delta t. Current produced is simply, that is delta phi divided by R delta t. Instantaneous current is this, and charge flow in is this. Let's talk about this question. Let's talk about this question. Radius of a circular loop placed in a perpendicular magnetic field is increasing at a constant rate, R0 meter per second. What does the question say? You have got a circular loop over here. It is placed in a constant magnetic field. It is placed in a constant magnetic field. Now, radius of this is, let's suppose, R at any instant. And the radius of this loop is changing, increasing. Means this is getting bigger. Now tell me, magnetic field is constant, but radius is getting bigger. If the size of the ring is getting bigger, don't you think that more number of field lines are going to cross the ring? If more number of field lines are going to cross the ring, will the flux remain same or it will change? Flux will change. So we say here, guys, listen to me very carefully. We say flux is going to change because flux is magnetic field into area. Guys, either if magnetic field changes, flux changes. If area changes, then also flux changes. Now it says if flux changes, how much will be the EMF? We know if flux changes, EMF is there. You say simply, sir, in this particular case, EMF is going to be minus d phi by dt. Okay. That will be minus d divided by dt of, what is flux? Flux is magnetic field into area. Okay. Now, this EMF you can write over here, that is minus. What is d divided by dt? What is magnetic field? Magnetic field is given as B. What is area of this loop? Area of this loop is pi r square. Pi r square. Okay. Area of the loop is pi r square. Now take common. Sir, B is constant. B is constant. Pi is constant. Take this common. So minus pi into B. Differentiation of r square, dr square divided by dt. Now the problem here is you are differentiating r with respect to t, which is not possible. Now do one thing. Do one thing. Multiply with dr and divide with dr. Again, it will get cancelled out. Interchange the position of this and this. So it will be minus pi and then b, then dr square divided by dr. Dr square divided by dr. Into, we say, dr divided by dt. Now see, what does the question say? Question says that the radius of the loop placed in a perpendicular uniform magnetic field is increasing at a constant rate. This means dr by dt. This is what we call the rate of change of radius with respect to time. With what rate radius is increasing? That is R0 meter per second. What does it mean? It means every second, how much radius is changing? R0. If I say dr by dt is 1 meter, means every second, what is the rate of change of radius? That is 1. Every second, 1 meter radius changes. So in first second, it will be 1. In the second second, it will be 2. In the third second, it will be 3. Okay. So dr by dt, it is basically R0 meter per second. You can put it over here. So this will be minus b, pi b. Differentiation of r square with respect to r, that will be 2r. And what is the value of dr by dt? That is R0. So what I can write over here, EMF will be, that is minus 2 pi b r and this R0. This R0. Okay. Tell me, is this clear? Is this clear? Oh, tell me quick. Is this clear? Hey, what language are you speaking in the chats? Speaking English, na? Ukda, Ukda, something writing in the chats. Tamil, Kannada. Huh? You guys are not supposed to speak in any other language apart from English. Okay. Now, let's move on to this question. A conducting ring of radius r is placed perpendicularly inside a time-varying magnetic field. Okay. So a ring is placed inside a time-varying magnetic field. This is a ring. Okay. And its radius is r. It is placed in a time-varying magnetic field. Value of magnetic field is given as B naught plus alpha t. What does the question say? EMF induced in the ring will be, guys, EMF in this particular case will be simply, that is minus d phi by dt. Okay. EMF will be minus d divided by dt of magnetic field into area. Area of the ring is pi r square. So you can say in this particular case, EMF will be minus d divided by dt. What is the value of magnetic field, by the way? It is B naught plus alpha t. And area is pi r square. Now this, guys, pi and r, radius is also constant, take this out. So minus pi into r square you can take out. Now differentiation of this, d divided by dt of B naught plus alpha t. Now B naught is an addition over here, you need to differentiate it. Now what is the differentiation of B naught? It will be 0. So minus pi into r square. Now differentiation of B naught is 0 because differentiation of constant is 0. What is the differentiation of alpha t? It will be alpha. So it will come out to be minus pi r square alpha. This is going to be the EMF in this particular case. Motional EMF, motional electromotive force. Guys, see, motional electromotive force is nothing but you have a magnetic field over here. Okay. And in this magnetic field, you have placed a rod. Length of the rod is L. And this rod is moving with a magnetic field, with a velocity V. This rod is moving with a velocity V. Whenever a rod moves inside a magnetic field, we say EMF is induced in the rod. Okay. I'll write over here, whenever a rod moves inside a magnetic field, EMF is induced in the rod. Okay. Whenever a rod moves inside the magnetic field, EMF is induced inside the rod. And that is BLV. B is the magnetic field, V is the velocity, L is the length. Now see, case 1. Take a look. When magnetic field and velocity are parallel, this is the magnetic field and this is the velocity. Okay, when magnetic field and velocity are parallel, they are in the same direction. In that case, EMF will be 0 directly. What did I say? Whenever a rod moves inside a magnetic field, EMF in that case will be 0. Okay. Oh, sorry, EMF in that case will be BLV. But the condition is, if magnetic field and velocity are parallel, EMF is 0. Even you see over here, magnetic field is inwards. Rod is placed something like this. So it moves something like this. So this length and this velocity, they are parallel. When velocity and length are parallel, here also EMF will be 0. Cool. Even in this case, my dear NEET aspirants, length and magnetic field are parallel. When length and magnetic field, this is magnetic field and length are parallel. In this particular case also, EMF will be 0. So means if any of the two, my dear NEET aspirants, are parallel to each other, EMF will be 0. So can I say all the three must be mutually perpendicular to each other? All the three, B, L and V, must be mutually perpendicular to each other. All the three, B, L, V, must be mutually perpendicular to each other. Must be mutually perpendicular to each other. Okay, must be mutually perpendicular to each other. Now take a look, my dear NEET aspirants. Find the EMF in the rod of length L and A. See guys. Velocity is forward in x-axis. Length is along y-axis. Okay. And magnetic field is inward, that is along z-axis. We say all the three are mutually perpendicular over here. So you can say in this particular case, EMF will be BLV. In this particular case, EMF will be BLV. Okay. Yes, absolutely. This magnetic field is basically being created because of this wire. Place your thumb along direction of current, curl your fingers. So this is the magnetic field because of the wire. Okay. In this particular case, could you please tell me how much is the EMF? Guys, because of this wire which carries current I, it produces the magnetic field here which is inward. And rod is moving something like this. You see L is along Y and velocity is along Y. L and V are parallel. So in this particular case, EMF is going to be 0. EMF is going to be 0. What about this one? What will be the value of EMF in this particular case? Guys, see. First of all, magnetic field is outward over here. Velocity is forward over here. Let's now calculate the length. How much is the length you guys are supposed to take? Don't say I'll take L plus L, that is 2L. No, you need to consider the effective length. This is the effective length. Now guys, see. Can I say if total angle is 120, so this will be 60 and this will be how much? 60. If this is L, this will be L cos 60. This will be how much? L sin 60. L sin 60. This will be how much? L sin 60. Now, this is what we call effective length. L sin 60 plus L sin 60. That is 2L sin 60. Join one end of the rod with another end. This is going to be the effective length. So, in this particular case, we say it is BVL effective. Whenever the rod is not straight, in that particular case, you take L effective. Now, what is going to be the effective length of this wire? You say, sir, L effective. L effective in this particular case will be, that is 2L sin 60. 2L sin 60 is basically root 3 by 2. 2 and 2 will cancel. So this will come out to be root 3L. So what will be the EMF in this particular case? EMF will be, that is BV into root 3L. This is the EMF. This is the EMF. Self-induction. What does self-induction actually mean? Guys, tell me in the chats, is this clear till over here? Quick. Tell me quickly. Is this clear? Come on, tell me, is this clear? Okay. Now, guys, take a look. What does self-induction actually mean? What does self-induction actually mean? See, let's suppose, my dear NEET aspirants, you have got a coil over here. This is the coil. Okay, this is the coil. And in this coil, current is flowing. In this coil, current is flowing. Okay. Now, due to this current, we say magnetic field is being produced in the coil. This you can consider as solenoid. This is what we call the solenoid. So we said that magnetic field will be something like this along the axis of this coil. This is the magnetic field along the axis of the coil. This is the magnetic field along the axis of the coil. Okay. Now, my dear NEET aspirants, see, this is the coil, something like this. Magnetic field crosses the area of the coil. It is along the axis. Don't you think that in this particular case, we say flux is being produced? Absolutely, sir. Because whenever the magnetic field whenever the magnetic field crosses the area, we say flux is being produced. So if this is the coil, my dear NEET aspirants, okay. So in this coil, I say current flowing is I. We say this is the magnetic field which is crossing. Now this magnetic field is crossing the area of the coil, so flux is being produced. Now, can I say, in this particular case, more you send the current, more field will be produced? If more field is produced, more will be flux, yes. So can I say this flux is directly proportional to current? More is the current, more is the magnetic field, more is the flux. Now, replacing the proportionality with a constant, and you use the constant as L. This L is what we call, my dear NEET aspirants, that is self-inductance. This L is what we call the self-inductance. This L is what we call the self-inductance. This L is what we call the self-inductance. And value of the self-inductance is this. Mu naught. Mu naught is the permeability of free space. N square. N means number of turns per unit length. Like if this is the coil, how many number of turns are there on the unit length? How many number of turns are there on the unit length? A is the area of the coil and L is the length of the coil. A is the area of the coil and L is the length of the coil. Okay. A is the area of the coil and L is the length of the coil. Okay. Okay. A is the area of the coil and L is the length of the coil. Now, my dear NEET aspirants, what I want you guys to do in this particular case is, let's suppose if I say current in the coil changes, we say due to that magnetic field changes. If current changes, magnetic field changes. If magnetic field changes, we say flux changes. And if flux changes, we say EMF is induced. Absolutely, sir. So if current in the coil, if current I in the coil is changing, we say magnetic field is also changing. So if magnetic field is changing, due to which flux is changing. And whenever flux changes, guys, listen to me very carefully. How do you write the change in flux? How do you write the change in flux? This is pi into R. How do you write change in flux? Sir, when current changes, so this is di divided by dt. This is called change in current. How do you write change in flux? Sir, this is d phi divided by dt and is equal to, instead of this L, you keep L only. So that is what is mentioned over here. If flux changes, this is d phi by dt. If current changes, this is di by dt, L as it is. Now tell me, what is the value of d phi by dt? According to the Faraday's law, we say d phi by dt is EMF. So I can say this is EMF is equal to d phi by dt is minus, EMF is minus d phi by dt. So take this minus over here. So instead of d phi by dt, I'll write negative EMF. Take that negative EMF over here. This is what we call the self-induction. This is what we call the self-induction. See, what does self-induction mean? If there is a coil, In that coil, current changes. We say in that coil, magnetic field changes. In the same coil, flux is being produced. In the same coil, EMF is being induced. And how much is that EMF? EMF is equal to minus L di by dt. So all this is happening in the one coil only. That's why we are calling it self-induction. Tell me guys, is this clear? That's why we are calling it the self-induction. Is this clear? Please tell me in the chats. Is this clear? That's why we are calling it the self-induction. Tell me guys, is this clear? Absolutely, absolutely. Now, my dear NEET aspirants. So self-induction is nothing but if all these things are happening in the same coil, this is what we call the self-induction. Okay, okay, yes. Now guys, see. The current passing through a choke coil, it means coil only of 500. So a coil is having inductance as 500. Is decreasing at the rate of 2 ampere per second. So di divided by dt. This is what we call change in current. It is 2 ampere per second. di by dt is given as 2 ampere per second. And I would write minus 2 ampere per second. Why? Because current is decreasing in this particular case. di by dt is minus 2 ampere per second. The EMF developed across the coil is, what will be the EMF developed? Guys, EMF will be simply, EMF developed across the coil is, EMF will be simply, that is, I would say L di by dt. So you can say EMF in this particular case will be minus L. What is the value of L? That is 5. What is the value of di by dt? That is minus 2. So this will come out to be plus 10 volts. This is the value of EMF. So what does self-induction mean? Guys, again I am repeating. If this is the coil, in this coil I would say current flows. In the same coil I would say magnetic field is produced. In the same coil I would say flux is produced. Now if this current changes, magnetic field changes, flux changes. So in the same coil EMF is being induced. So all this is happening in one coil. That's why we call it self-induction. Induction means production of EMF. And that EMF will be minus L di by dt. This is what we call the self-induction. This is a question NEET 2016. A long solenoid, solenoid means this coil only, has 1000 turns. When a current of 4 ampere flows through it, there is a solenoid. It has got number of turns as 4000. Current in the solenoid is 4 ampere. Flux linked with each turn is 4 into 10 raised power minus 3. It says that flux through one turn. How much is the flux created through one turn? 4 into 10 raised power minus 3. This is the flux through one turn. 4 into 10 raised power minus 3. The self-inductance of the solenoid is. Guys, see. If this is the flux through one turn, what will be, how many number of turns there? 4000. What will be flux through 4000 turns? You say, sir, 4000 into 4 into 10 raised power minus 3. Okay. This will be the flux through 4000 turns. This will be the flux through, okay, 1000. Number of turns is 1000. Flux through 1000 turns. Now this is 10 raised power plus 3, 10 raised power minus 3. So this came out to be 4. This is net flux. Flux through 1000 turns is net flux. Now, can I say in this particular case as this net flux is equal to minus, it is equal to minus L di by dt. Absolutely. Now, how much is this? This is 4 is equal to minus L. Okay, leave minus aside because minus is just tells you supporting or opposing. This is L di by dt. Okay. So don't use this one because we need to find what self-inductance. Use this flux is equal to L into I. Flux is given as 4. L you need to calculate. I is given as 4 ampere. This and this is L will come out to be 100. L will come out to be 100. Okay. One more this question. One more question of this pattern. One more question of this pattern. Okay. One more question of this pattern. Guys, tell me in the chats, is this clear till over here? Tell me, guys, is this clear? Yes. Now, guys, see. Let's suppose if they ask you to find the potential difference between A and B. Listen to me very carefully. How do you solve this pattern of question? How do you solve this pattern of question? See, in this particular question, you select the path. Let's suppose from A to B. You select the path from A to B. Now, what you guys are supposed to do is, listen to me very carefully. You have to mention the potential drops of every load over here. Like you have to mention what is the potential difference here, what is the potential difference here, what is the potential difference here. In case of resistor, in a resistor. If I ask you, tell me what is the potential difference, how do you find the potential difference? V is equal to I into R. So V is equal to, what is the current flowing here? That is 4. What is the resistance of this? That is 2 ohm. So potential difference is 4 2s are 8 volts. Done. Potential difference of battery is 5 volt. What is the potential difference in case of in an inductor? In an inductor. This is what we call inductor, solenoid, coil, whatever you say. How do you find over here? Recently we studied, sir, V is equal to L di by dt. V is equal to L di by dt. Okay. V is equal to L di by dt. Now tell me, or EMF is equal to L di by dt. Now tell me in this particular case, this V is equal to, what is the value of L? L is given as 10. And what is the value of this di by dt? Di by dt is also given as 10. So this is given as 100 volts. This is given as 100 volts. Now, my dear NEET aspirants, what I want you guys to do in this particular case is, so you got potential difference here. You got potential difference here. Now replace these with the batteries. Replace these with the batteries. Means you have to draw the batteries over here. I'll draw it like this. Replacement of this with a battery is, you will make a battery. Battery is this. What you guys are supposed to do, if you have to find potential difference between A and B, first you select the path. Let's suppose from A to B you are moving. Then you find potential difference in resistor. Then you find potential difference in the inductor. These two formulas. Then make a battery. Sir, current always flow from, this is the direction of current, 4 ampere. Current always flow from higher potential to lower potential. So this will be at higher potential, this will be at lower potential. So means you make the positive terminal from this side, negative terminal from this side. This is positive and this is negative. This is positive and this is negative. Then my dear NEET aspirants, keep this battery as it is. This is 5 volts. Then here, guys, if this current and this current is increasing, if the primary current is increasing, will the inductor, will the coil support it or it will oppose it? It will oppose it. How will it will oppose? It will oppose by producing secondary current. By producing secondary current. If primary current is increasing, so this will oppose. Remember it here. This will oppose by producing the secondary current in the opposite direction. Now guys, always remember, my dear NEET aspirants, always remember one thing. If I say this is the battery over here, if I say from this battery current is coming out, current will always come out of the positive terminal. It is not possible current will come out of the negative terminal. No, current comes out of the positive terminal. Now here, if this is the primary current increasing, this will send the secondary current which will oppose it. So that is only possible if you make the positive terminal from this side, negative terminal from this side. So it is going to be like this. And this will be 100 volts. This is A and this is B. Now you have selected the path from A to B. You have selected the path from A to B. Potential difference of this is 8 volts. If you have selected the path from A to B, first you will be mentioning the potential of A. Then in case of the battery, in case of this battery, what is the potential difference? 8 volts. Sir, plus 8 or minus 8. See, this is your path. You are moving from higher to lower. If you are moving from higher potential to lower potential, take this minus. Here also you are moving from higher to lower, so minus 5 volts. Here also you are moving from higher to lower, so minus 100 volts is equal to VB. So last point you mentioned at VB. What did I say, guys? How do you find the potential difference here? First you write the potential difference of this. Potential difference of this, V is equal to IR. Then you write potential difference of this, V is equal to L di by dt. Then you replace this V with batteries. Here, this will be positive, this will be negative. Why? Because current flows from higher to lower. Here, if primary current is increasing, we say secondary current will oppose it. It will create secondary current which will oppose it. So that is only possible if this is positive terminal, this is negative terminal. Because current always comes out of the positive terminal. So this will be VA minus 113 volts is equal to VB. So take it over there. VA minus VB will come out to be 113 volts. Guys, tell me in this particular case, is this clear? Tell me quick. Is this clear? Is this clear quick? Do smash the like button, guys. If you are not like the session yet, do smash the like button. Let's move on to mutual inductance or mutual induction. See, guys, in self-induction, what did I tell you? In the same coil, current flows. In the same coil, magnetic field changes. In the same coil, flux changes. In the same coil, EMF is being induced. But when it comes to the mutual induction, current flows in one coil and EMF is being produced in another coil. That is what we call the mutual induction. Mutual. Now see, in this particular case, in the coil 1, we say current flows. In the coil 2, EMF is being induced. This process is what we call the mutual induction. This process is what we call the mutual induction. And here. If I say, guys, listen to me very carefully. I'll make you understand. Can I say more is the current over here? See. Because of this coil, listen. Because of this coil, if the current is flowing in this coil, it will create the magnetic field at this point. It will create the magnetic field at this point. Okay. Now guys, see, because of this current flowing in the first coil, it creates the magnetic field in the second coil. Now, if this current increases in the primary coil, magnetic field in the secondary coil increases. And that magnetic field is crossing the secondary coil. So flux is being produced in the secondary coil. So can I say flux in the secondary coil is proportional to the current in the primary coil? Yes, sir. So can I say over here, this flux will be equals to M into I. Flux will be equals to M into I. Flux will be equals to M into I. So this M is basically the coefficient of mutual inductance. This is coefficient of mutual inductance. And value of this M is actually mu naught R1 square, R2 square, then pi divided by 2x cube. R1 is this radius, R2 is this radius, distance between them is x. Now, my dear NEET aspirants, listen to me very carefully. I'll show you. If this current changes, how do you write change in current di by dt? Due to this change in current, this flux changes. That is d phi by dt. Absolutely, sir, is equal to m. Now, what is d phi by dt? That is EMF. So this EMF comes out to be equal to this EMF in the secondary coil. By the way, this is the EMF created in the secondary coil will be equals to minus is because of Lenz law. This will be di by dt, and this change in current is in the primary coil. Okay, so this is what we call production of EMF in the secondary coil due to the first coil. This is what we call the mutual induction. This is what we call the mutual induction. Now, you have the question in this one. Let's suppose you have a primary coil, you have a secondary coil. Decrease in the current in the primary coil from 2 ampere to zero value in 0.01 seconds. So, in the primary coil, current is decreasing. Okay. How much? From 2 ampere to 0. In how much time? Guys, see, di, change in current in this particular case. Okay. So, from 2 ampere to 0 in 0.01 seconds. EMF is being created in the coil 2. In the coil 2, EMF is being created. That is 1000 volts. So what is the mutual inductance over here? Guys, how do we write? EMF in this particular case will be, that will be simply M di by dt. Even you can write minus M di by dt. Since here current is decreasing, that minus into minus will again become plus. EMF created over here is 1000 volts is equal to M di, change in current from 2 ampere to 0, it is 2. In how much time? 0.01 seconds. So 0.01. So this will be 1000 is equal to 2M divided by 0.01 means 1 by 100. 100 will go in the numerator. 0, 0, 0, 0. 2 ones are 2 5s are. So M will come out to be 500. M will come out to be 500. So we are done with basically what? EMI. Done with EMI. Done with EMI. This was the last topic. Okay. Now guys, let's start AC, alternating current. Let's start alternating current. Okay. Take a look, my dear NEET aspirants. Before starting the alternating current, let's talk about the direct current. Let's talk about the direct current. What does direct current actually mean? Direct current means unidirectional current. Direct current is that current which is unidirectional. Unidirectional means which flows only in one direction. Let's suppose, my dear NEET aspirants, I take a circuit over here. This is the circuit. This is the circuit that I am taking over here. And in this circuit, my dear NEET aspirants, current flowing is I. I is the current flowing. And always remember, when you make a circuit, listen to me very carefully. Let's suppose this is the resistance over here. And you connect a battery over here. This is what we call circuit. Always remember, my dear NEET aspirants, we say current comes out of the positive terminal and it enters the negative terminal. It moves something like this. The direction of the current can never be like this. It will always be from positive to negative. So this is what we call unidirectional current. Always from positive to negative. So current comes out of the positive terminal and goes in the negative terminal. This is what we call the direct current. Okay. And here, if the current comes out of the positive terminal and enters the negative terminal, So you consider this current as positive. So this current will be always positive. So if you make the graph, so this current is always positive. This is the graph of direct current. Whenever you see the current positive only, that is what we call the direct current. So direction is only clockwise. It is only from positive to negative. Sir, is this AC or DC? This is a DC. This is a DC, direct current. Why? Because in this case, current is positive only. Positive only. Sir, but magnitude is changing. Okay, it is changing. Doesn't matter. So we say magnitude is changing, but here also current is positive, positive. If the graph becomes, if you make the graph from the lower side also, then the direction of the current changes. Then the current becomes negative. So this is a direct current. And when it comes to the alternating current, what does alternating current mean? It means a bidirectional current. This alternating current will have two directions. It can be positive, it can be negative. I can be positive, I can be negative. Like. Let's suppose you take an AC source over here. This is called AC source. AC source means that source which gives the alternating current. Okay. Okay. Yes. Now, my dear NEET aspirants, in this particular case, it can send the current like this also. It can send the current like this also. This will be negative and this current you consider as positive. One cycle positive, another cycle negative. So that's why we call it bidirectional current. If you make the graph, guys, the graph would be something like this. Graph would be something like this. From the upper side, you consider current as positive. From the lower side, you consider current as negative. So this is positive and this is negative. Sir, is this also the alternating current? Yes, absolutely. This is what we call square wave AC. This is called sinusoidal AC. This is called square wave AC. So here current is positive and it is constant for certain time. Then it becomes negative. Then again it becomes positive. Then again it becomes negative. Tell me, is this clear? Sir, what about this? This is also an AC. This is which AC? Triangular AC. Okay. Or this is what we call the sawtooth AC. Sawtooth AC, that is the actual name of this. Like this one. Guys, this is sinusoidal AC. In this particular case, current is positive and negative. Okay. And when it comes to this is called triangular AC. And this is the sawtooth AC. You have seen that chainsaw, okay, which is used to cut the trees. That chainsaw looks like this now. That's why we call it sawtooth AC. Current is positive as well as negative. Triangular AC, positive as well as negative. This is square wave AC. So in our syllabus, we have to discuss this sinusoidal AC. And this is not an AC. Current is positive only. Current is positive only. What about this? This is not an AC. Why? Because it is not periodic. Why? In this particular case, my dear NEET aspirant, peak value is decreasing. See, this is called amplitude. Peak value is decreasing. See, peak value is decreasing. So this is not an AC. So peak must remain the same. Peak must remain the same. Tell me, is this clear till over here? Is this clear till over here? Come on, quick. Is this clear till over here? Tell me, guys. Quick. I want you to tell me in the chats if this is crystal and clear till over here. Clear na? I won't forget it. Hey, teamwork JE. I'll send you the notes. Chill. Take a chill pill. Class 12th part 1. Okay. Now guys, take a look exactly over here. Listen to me very carefully. In our syllabus, we have to basically discuss what? we have to mostly discuss the sinusoidal AC. In our syllabus, we have to discuss what? We have to discuss the sinusoidal AC. Listen to me very carefully. I want you guys to give me 100% attention. Sinusoidal AC is this AC. This is the sinusoidal AC. This one. This is the sinusoidal AC. In this particular case, current is positive from upper side and current is negative from lower side. So in our syllabus, we have to discuss this sinusoidal AC only, which is positive from the upper side and negative from the lower side. Okay, absolutely. Now, how do you write the equation of the sinusoidal AC? How do you write the equation of the sinusoidal AC? How do you mention? Like if you say, sir, current value of current is 3 ampere. That 3 ampere is direct current, that is DC. That 3 ampere is what? Direct current, that is DC. But if you have to write the equation of this, how do you show this current? This is the way to show the current. This one. That is I naught sine of omega t plus phi. I naught sine of omega t plus phi. What is this I naught? I naught is the maximum value of the current, peak value of the current. Like if I say I'll make it over here, I'll make the bigger graph. Okay. Something like this. Just a second, guys. Okay. Something like this. Something like this. Now, my dear NEET aspirants, in this particular case, this is what we call the peak value. This is what we call the peak value. What can be the maximum value of the current? That is what we call the peak value. Okay. And I is the instantaneous value. Current at any time. Current at any time. Like sir, at this time, what is the value of this current? Sir, this is the value of the current at this time. Okay, at this time, T. Sir, at this time, this is the value of the current. And this omega is what we call the angular frequency. Omega is what we call angular frequency. And this phi is called phase difference, or you can say initial phase also. This entire thing is what we call phase. This is called initial phase, or you can say phase difference also. Phi. Yes, sir. Yes, sir. Now, what does amplitude mean? Amplitude means the maximum value of current in either directions is called peak value or amplitude of the current. It is represented by I naught. Peak to peak is 2 I naught. Means this is I naught, this is I naught, minus I naught. So peak to peak is 2 I naught. This is 2 I naught. Okay. Time period. Time period means the time taken by the alternating current to complete one cycle of variation is called time period. To complete one cycle, See, I'll show you one cycle. Listen carefully. Listen carefully. Listen carefully. See, guys. I'll show you one cycle. So, till here it is half the cycle. Till here it is one cycle. And how much time it takes, guys? When here alternating current is 0. Here alternating current reaches maximum. How much time it takes in becoming the maximum? I would say this time is T by 4. Because in one time period T, it completes the cycle. In one time period T, guys, I'll make you understand. When it comes to the alternating current, in one complete time period, it first becomes maximum, then it becomes minimum, then it becomes maximum from the negative side, then it becomes minimum from the negative side. Because when you say alternating current, my dear NEET aspirants, when you say alternating current, just a second, you show it like this now. You show it like this also. This will be the positive. This will be negative. So basically, when positive cycle becomes maximum, then minimum, it means half the cycle. When negative cycle becomes maximum, then minimum, it means another half. So total is one complete cycle. Total is one complete cycle. Total is one complete cycle. Okay. So in how much time it becomes maximum in the positive cycle T by 4. So again, it becomes minimum, that is T by 2. And this time will be 3T by 4. And this time over here will be T. So in T by 4, it becomes maximum. In T by 2, it becomes minimum. In 3T by 4, it becomes maximum from the negative side. And in complete T, it becomes again minimum. This is what we call the one time period. This is what we call one time period. This is time period. This is amplitude. Frequency. Frequency means number of cycles completed by an alternating current in 1 second is called the frequency. Like guys, see. Tell me, listen carefully, please. In one cycle, alternating current changes direction how many times? How many times alternating current changes direction in one cycle? Sir, I think in one cycle it changes direction twice. Because in half the cycle it is positive, in another half it is negative. So now tell me, in 3 cycles, how many times it will change the direction? 6 times. In 10 times, in 10 cycles, how many times it will change the direction? 20 times. Now, what does frequency mean? Frequency simply means number of cycles per second. In 1 second, how many cycles it will complete? Like, sir, if I say in 1 second, in 1 second, it completes 10 cycles. 10 cycles. What does it mean? It means that in 1 second, it changes direction 20 times. It changes direction 20 times. 20 times it becomes positive, negative, positive, negative, positive, negative. That's how we define. That's how we define frequency. Number of cycles per second. Number of cycles per second. Okay. Now let's take a look at this particular question. How do we solve this particular question? I would want you guys to focus exactly over here. In an alternating current, current is given as I is equal to 100 sine of 200 pi t. This is the current which is given, 100 sine of 200 pi t. In this circuit, current rises from 0 to peak value in time. You have to tell me current will rise from 0 to peak value in how much time? See, if this is the alternating current, my dear NEET aspirants, I can make its graph something like this. If I say in how much time it will rise, it will become 100. Let's suppose 100 is somewhere around over here. How much will be the time in which it will become 100? Whenever you face a question something like this, guys, because this alternating current is variable, it will be 0, maximum, minimum 0. So now you tell me in this particular case and how much time it will become 100. So to find the time in which current becomes 100. You have to tell me the time in which current becomes how much? 100. Listen carefully. Put the value of this I as 100 is equal to, and this will be over here 100. Then you say sine of 200 pi t. Then you say sine of 200 pi t. Now 100 and 100. If I say in how much time it will become 50, you'll put 50 over here. You'll put 50 over here. So 100 and 100 will cancel. It will be 1 is equal to sine of 200 pi t. When is the value of sine as 1? Sine 90. So you can write sine of pi by 2 is equal to sine of 200 pi t. Now sine pi will cancel. So 1 divided by 2 is equal to 200 t. So t will be equals to 2 into 200, 1 divided by 400 seconds. So in the time 1 by 400 seconds, it will become maximum. In the time 1 by 400 seconds, it will become maximum. Let's suppose you have this question. The peak value of an alternating EMF is given by, this is the alternating EMF, E is equal to E naught cos of omega t. The peak value of the alternating EMF means peak value is E naught. It is given as 10 volts. It is given as 10 volts. And the frequency is 50 hertz. Frequency is 50 hertz. So one thing you will remember, my dear NEET aspirants, we say this angular frequency omega, we can say it is 2 pi divided by T. Even you can write this omega as 2 pi into F also. And you can say this frequency is inverse of time period. These three things you will just remember. Okay. These three things you just remember. Now you tell me one thing, my dear NEET aspirants over here. It says, and time in this case is given as 1 by 600 seconds. At time 1 by 600 seconds, the value of instantaneous EMF is. You guys are supposed to tell me the value of EMF in this particular case. You guys are supposed to tell me the value of EMF in this particular case. See guys, you have to find the value of this E, this EMF, which is equal to E naught. Put the value of E naught, that is 10. Then we say cos of omega, you can write 2 pi into F because frequency is given and time is T. So you can write over here 10 cos of 2 pi. What is the value of frequency, by the way? That is 50. Okay. And time, T is 1 by 600. So you have to tell me at this time what will be the instantaneous value. 2 ones are, okay, 0 and 0 will cancel. 5 ones are, 5 12s are. 2 ones are, 2 6s are. So this will come out to be 10 cos of pi by 6. This pi divided by 6. Pi by 6 means 30 degrees. Cos 30. Cos 30 is 1 by 2. So this is 10 into 1 by 2. Cos 30 is root 3 by 2. This is root 3 by 2. 2 ones are, 2 5s are 10. So it will come out to be 5 root 3 volts. So EMF came out to be 5 root 3 volts. EMF came out to be 5 root 3 volts. There is one more question, J Mains 2022. And here current is given by, I'll write I is equal to 5 sine of 120 pi t. What does the question say in this particular case? The question says, okay, the current flowing through an AC circuit is given as this. How long the current will take to reach the peak value starting from 0? It says how much time it is going to take the peak value. What is the peak value over here? 5. So put 5 over here. I is equal to 5. Put 5 over here. 5 is equal to 5 sine of 120 pi t. 5 will cancel. It is 1 over here. So sine 1 means sine pi by 2 is equal to sine of 120 pi t. Sine pi will cancel. So t will come out to be 120 into 2. That is 240. 1 upon 240 seconds. So in 1 by 240 seconds, it is going to reach the peak value. It is going to reach the peak value. So here, when current becomes, okay, in the 0 to peak, here also it asks for peak. Peak here is also how much? 100. So this is peak, I naught. Tell me, is this clear? Guys, smash the like button if you have not liked the session yet. Come on, quick. Tell me in the chats, is this clear? Quick. Tell me in the chats, is this clear? Quick. Just a second. Now guys, average value. How do we actually find the average value? Listen to me very carefully. Let's suppose you have a quantity. Okay. If you want to find its average, you mention it like this. Okay. So its average value we can find it like this: integration of x dt upon integration of dt. Let's suppose you have current. If you have to find the value of current, so you'll be saying integration of current dt upon integration of dt. This is the way we can find the average value of any quantity. Okay. Yes. Let's suppose you have sine of omega t. How can you find the sine omega t's average? Put this in the brackets. So integration of sine omega t dt upon integration of dt. This is the way. This is the way actually. But I would want you guys to directly remember over here. By using the same formula, we have calculated the average of sine omega t. Sine omega t means if we have the graph of sine, if we make the graph of sine, it would be something like this. If we make the graph of sine, if we make the graph of sine, if we make the graph of sine, it would be something like this. So means this is time 0 over here, this is time capital T. If I say in one complete cycle from 0 to t, complete cycle means from 0 to t. Half cycle means from 0 to t by 2. What is the average of the sine omega t in full cycle from 0 to t? Like, let's suppose you have this question. Current is flowing through a wire, this. Find the average between t is equal to 2 to t is equal to 5 seconds. How do you find the average of current? Listen carefully. Integration of I dt upon integration of dt. Integration of I. What is the value of I? That is 2t. Upon integration of dt. From where to where? 2 to 5. So this is 2, this is 5. This is 2, this is 5. Now tell me, my dear NEET aspirants, how am I supposed to write in this case? How am I supposed to write in this particular case? So this 2, what is the integration of t? It will be t square divided by 2. From where to where? From 2 to 5. Upon integration of dt, it is going to be t. From where to where? From 2 to 5. 2 and 2 will cancel. Now in this t you put the upper limit, that is 5 square, minus you put lower limit, that is 2 square, divided by. In this t you put upper limit 5, minus lower limit is 2. Now 5 square is 25, minus 2 square is 4, upon, this will be 3. This is 20 minus 1 by 3. This will come out to be 7. So 7 ampere is the average of this. Similarly, if I am saying what is the average of sine omega t from 0 to t in full cycle, it is 0. What is the average of cos omega t in full cycle? It is 0. Okay. If I say what is the average of sine square of omega t in full cycle? 1 by 2. Cos square omega t in full cycle? 1 by 2. Sine omega t in half cycle. Half cycle means t by 2. Half cycle means t by 2. So it will be 2 by pi. For cos omega t, 2 by pi. Sine square omega t, 1 by 2. Cos square omega t, 1 by 2. This will be the average of these quantities. One more important thing. RMS value. RMS value is nothing but root mean square value. RMS value is nothing but root mean square value. Okay. Now the question is, how do we calculate the RMS value? Guys, directly I would want you guys to remember, whenever you have a quantity, let's suppose this quantity. This is a sinusoidal current. If you have to find its RMS value, IRMS, first you do the squaring of this. First you do the squaring. Square of this, square of this. Then you find the average. Average means you put the bracket. Okay. Then you apply the root. Final result, I won't be doing that in detail over here. That's just the derivation. Final result will come out to be I naught by 2. I naught is peak value divided by root 2. So from now onwards, if somebody asks you, what is the RMS value of sinusoidal current? You will say I naught divided by root 2. This is the RMS value of sinusoidal current. Okay. Yes. Now guys, take a look. Take a look. Take a look. One more important thing. Let's suppose you have a question over here. I is equal to 100 sine of 400 pi t. What will be the RMS value of this current? You say, sir, IRMS in this particular case will be peak value divided by root 2. What is the value of peak value? That is 100 and divided by root 2. This will be the peak value over here. Now, mixture of AC and DC. Guys, when you say the direct current could be like this: 3 ampere, 4 ampere, 7 ampere, 10 ampere. Okay. And alternating current could be like this. I would say 4 sine of 200 pi t, something like this. This can be direct current. This will be the alternating current. If you have mixture of AC and DC, see, I1 is DC. This is AC. This is DC and this is AC. And if you have to find its RMS value, you'll be simply saying its RMS value will be, that is I1 square. That is this square, I1 square. Okay. Then plus I2 square divided by 2. So keep this thing in your mind, my dear NEET aspirants. You take the peak value of this AC and divide it with 2. Don't divide the 2 here. Divide the 2 to the peak value of alternating current. Okay. Like here, what is the value of IRMS over here in this particular case? You say this is I1 and this is I2. You say under root of I1 square, that is 4 square, plus I2 square, 5 square divided by 2. So this is going to be under root of 4 square is 16 plus 25 divided by 2. Solve it and you'll get the answer. Okay. If you have, my dear NEET aspirants, something like this. This is what we call mixture of AC and AC. This is AC and this is AC. If you have the mixture of AC and AC, and you guys are supposed to find its RMS value, you'll be simply saying, sir, RMS value here will be I1 square plus I2 square divided by 2. I1 square plus I2 square divided by 2. Okay. Yes. Guys, tell me in the chats, is this crystalline clear? Tell me, come on, quick. Is this crystalline clear? Is this clear? Now guys, take a look in this particular question. Representation of AC, okay, alternating current and voltage by a phasor. Listen to me very carefully. How do you mention this on the phasor diagram? Now guys, take a look. Let's suppose we have 3 currents. I is equal to I naught sine omega t plus phi. Second is I is equal to I naught sine omega t minus phi. Okay. And third is I is equal to I naught sine omega t. In this particular case, you guys are supposed to plot this on the graph. See. If you take a look over here, this I naught sine omega t only, it has plus minus phi, how much? 0. It is starting from the origin. It is starting from the origin because it is having the initial phase as 0. And this one, I naught sine omega t plus phi, it is starting from, you can clearly see maximum. It is starting from, don't see this because you have to check from the origin itself. It is starting from maximum. It is starting from maximum because it is sine omega t plus phi. Okay, here it is in lead. Here, when you say plus, means it is starting from maximum. And here it is minus phi. So it will be starting from minimum. First one from origin, this will be starting from minimum. Sine omega t minus phi. Okay, sine omega t minus phi. I believe this is clear. So this is representing on what? Graphs. Now we'll represent these on phasor diagram. Now see, how do we represent these on phasor diagram? Listen to me very carefully. If you have to represent these on phasor diagram, we'll represent it something like this. Take a look, guys. Okay, just a second. I'll add a page. We have to represent this on the phasor diagram. Okay, so we'll be making it according to the graph only, like the graph only. On this x-axis, we mention sine omega t. Okay, on this side, we mention minus sine omega t. Keep this thing in your mind. Plus sine omega t, minus sine omega t. On this axis, we mention cos omega t. This is cos omega t. And on this axis, we mention minus cos omega t. We mention minus cos omega t. Plus sine omega t, minus sine omega t. Plus cos omega t, minus cos omega t. Now guys, first axis, first one. I naught sine omega t, this one. We need to mention this on this axis only, x-axis only. Why, sir? Because it is sine omega t only. So mention it on this axis only. So this is I would say I1. This is I would say I1, or I would say I naught sine omega t. And the second one is in I naught. If you check this one, or this one, sine omega t plus phi, it is in lead phi. So this current, which is sine omega t plus phi, it leads the previous current by phi. So you'll be making it like this. You'll be making it like this. Okay. And this will be I naught sine of omega t. Then you say plus phi. And this angle you will be considering over here. Because it's in lead phi. And the third one you'll be making it like this. Okay. And this would be also phi. But this current would be I naught sine of omega t minus phi. Because it is in lag phi. It lags sine omega t by phi. This angle is also phi. This is how do you represent on phasor diagram. Let's suppose you have these currents. You guys are supposed to plot these currents on the phasor diagram. Let me plot these currents on the phasor diagram. Okay? Yes, absolutely. Let me plot these currents on. Okay? Let me plot these currents on phasor diagram. Okay? Now guys, take a look. On this axis, I'll be mentioning what? Sine omega t. That's what I told you recently. On this axis, I'll be mentioning what? Minus sine omega t. On this axis, it is cos omega t. On this axis, it is minus cos omega t. Okay. Now guys, if I say first one, 4 sine omega t plus pi by 6. 4 sine omega t plus pi by 6. Guys, see. If it was only sine omega t, I would have made on x-axis, but it is plus pi by 6. Plus pi by 6 means anti-clockwise. Minus means clockwise. So plus pi by 6. So you'll be making it like this. Okay. And this will be I1. And this angle is pi by 6. Pi by 6 means how much? 30 degrees. Second one is 5 cos omega t minus pi by 3. Guys, it is cos. If it was only cos omega t, I would have made on biaxes. But it is minus pi by 3. Minus means clockwise. And pi by 3 is how much? 60 degrees. If this is 30, so 60 would be on this line. Right? Total is 90, na? If this is 30, this will be pi by 3. Pi by 3. Okay. So then this would be the second one. I'll make this bit longer. Why, sir? I2. Why am I making bit longer? Because amplitude of this is 4, amplitude of this is 5. That's why I'm making it bit longer. That's why I'm making it bit longer. Third one, 4 cos omega t minus pi by 2. Okay. So this third one is, if it was only cos omega t, I would have made on this axis, but it is minus pi by 2. Minus pi by 2 means minus 90. From here, you have to go backward minus 90. So it will be on this line. Yes, on sine. So this will be I3. What about I4? 3 cos omega t. It is along cos only. So this is I4. It is along cos only, plus minus nothing. Minus 4 sine omega t. Minus 4 sine omega t will be this. This will be I5 along minus sine omega t. 4 cos omega t plus pi by 3. Guys, this is cos omega t. Plus pi by 3 means anti-clockwise. This will be I6 and pi by 3 means this angle. And that is 60 degrees. Guys, tell me if this phasor diagram is clear. If this phasor diagram is clear to everyone. If this phasor diagram is clear to everyone. Quick. Tell me. Okay. Now guys, let's talk about this topic. That is AC source across pure resistance or pure resistive circuit. See. AC source means that source which provides the alternating current, DC source means which provides direct current, unidirectional current. AC source means which provides alternating current. Okay, AC source means which provides alternating current. Now, my dear NEET aspirants, what I'm trying to say in this particular case is, you have got a resistance over here, this resistance. And this resistance is connected to this AC source. This is the symbol of AC source. Symbol of DC source is this. Now, this AC source has got how much voltage? This is V0 sine omega t. Now, this AC source is going to send the current. Which one? Direct current, alternating current. It will send alternating current to this resistor. Now, my dear NEET aspirant, this is the voltage given by the resistance. And this voltage, this is the voltage of the battery. This battery will send the current, alternating current, that will go into this resistance. So, potential difference across the resistance is VR. Potential difference across the resistance is VR. Okay. Potential difference across the resistance is VR. Now, my dear NEET aspirant, if somebody says, how much is this potential difference across the resistance VR? Sir, since this resistance is directly connected to the load, same potential difference will be given over here. Okay, tell me, how much is the value of the current? You need to find the value of the current. How will you find the value of the current? Guys, you will be using V is equal to IR. Okay. So, I you can say that will be simply V divided by R. Now, instead of V, you can write that is V0 sine omega t divided by R. Now, this peak voltage divided by resistance, this will be equals to I is equal to I0 sine omega t. Peak voltage by peak resistance is I0 sine omega t. Okay, absolutely, sir. Now, guys, in this pure resistive circuit, I want you to focus on two things. This voltage and this current. Okay. Now, plot the phasor diagram of this voltage and current in case of pure resistive circuit. See, guys, this is the voltage. This is the current. You need to make this on the phasor diagram. Don't you think that in this particular case, guys, on the phasor diagram, this current will be along plus X and voltage will be along plus X. So we say voltage and current will be in the same direction. What does it mean? It means voltage and current are in the same phase. It means voltage and current are in the same phase. It means voltage and current are in the same phase. In case of pure resistive circuit, we say voltage and current are in the same phase. Absolutely, sir. Okay. AC source across pure inductor, or you say pure inductive circuit. AC source across pure inductor, or you say what? Pure inductive circuit. Pure inductive circuit means in which you have inductor connected to AC source. Okay. Now guys, here also, this AC source will send the current, alternating current. Here also AC source will send the alternating current. Like in pure resistive circuit, it sent the alternating current. This voltage sent the alternating current. That is this one. Similarly, in this case also, it is going to send the alternating current. So here we say, guys, directly remember, I will not derive it right now. This is the voltage given by the alternating source. And this voltage, this battery will send the current of this one. I naught minus I naught cos omega t, minus I naught cos omega t. Okay. This is the voltage and current in case of pure inductive circuit. Pure inductive circuit means that circuit in which only inductor is connected to AC source. Now let's make the phasor diagram of VL and I. VL means voltage across inductor. Okay. And VR means voltage across resistor. This is VR. Now guys, see. What is this? Minus I naught cos omega t. This is V naught sin omega t. If you want to plot this on phasor, cos omega t minus cos, sin minus sin. So current will be on this, minus cos omega t. Okay, voltage will be on this. This is V naught sin omega t. You can clearly see over here. Okay. So can I say in this particular case, guys, this current lags behind voltage. This current lags behind voltage by how much? Pi by 2. Even you can take it like this also. You can take it like this also. You can make the voltage from upper side, current in the forward direction. Because here also, this phi is pi by 2. Here also, voltage leads current by pi by 2. Or current lags voltage behind by pi by 2. Here also, it is behind pi by 2. So what did I tell you as of now? In case of pure resistive circuit, voltage and current are in the same phase. In case of pure inductive circuit, we can say voltage leads current by pi by 2. Okay. In case of pure capacitive circuit, in which you have capacitor and alternating source, here voltage is this, current will be I naught cos omega t. If you want to plot this on phasor, tell me. Guys, this is V naught sin omega t. It will be along x-axis. This is VC, voltage across capacitor. This is I naught cos omega t. It will be along this. This will be current along cos. Now you can rotate it also. You can write it like this also. Guys, tell me here. Which one lags or which one leads? Here current leads voltage by pi by 2. Voltage lags current by pi by 2. You can make it like this also. Make the current in the forward direction and voltage in the downward direction. See, it is exactly, its meaning is also the same. Voltage lags current by pi by 2 or current leads voltage by pi by 2. See. Now series LCR circuit. Is this clear? Is this clear, guys? Is this clear? Is this clear? Tell me. Now guys, take a look. Series LCR circuit. Okay. Series LCR circuit means in which you have inductor also, capacitor also, resistor also. So this is the alternating source connected to this. And voltage sent by the alternating source is V is equal to V naught sine omega t. So this is the voltage across inductor. This is the voltage across capacitor. This is the voltage across resistor. Voltage across resistor, capacitor, inductor. This is V is equal to V naught sine omega t. Now guys, in this particular case, if you have to make the phasor diagram, how do you make phasor diagram? Recently you studied. Sir, VR and current will be in the same phase. Voltage across resistance and current will be in the same phase. Why? Because voltage and current are in the same phase. So that's why I made the parallel. And this VL must lead current by pi by 2. You can clearly see over here. VL leads current by pi by 2. Okay. Clearly you can see over here. VL leads current by pi by 2. Okay. And VC lags current by pi by 2. You see, VC lags current by pi by 2. So can I say in this particular case, this will be from upper side, this will be from lower side. This is called the phasor diagram of LCR circuit. This is called the phasor diagram of LCR circuit. Now, let's suppose by any chance, if this becomes greater than this, if VL becomes greater than this, so then the resultant will be VC minus VL. This minus this factor minus this factor. If VL is greater than VC, so resultant will be VC minus VL. And this is VR. In this particular case, this will be V net. In between the two, this will be V net. Now, V net will be what? Under root of this square plus this square. Hey, you can do the vector sum over here. No? Under root of VL minus VC whole square plus VR square plus VR square. This will be the net voltage in this case. Okay. This will be the net voltage. Now let's make the impedance diagram. In the impedance diagram of LCR, we show it with the resistances. Guys, see. Listen carefully. Listen carefully. What I want you guys to understand over here is, we say in case of resistance, we say V is equal to I into R. Voltage is equal to current into resistance. In case of capacitor, we say V is equal to I into XC. This XC will be equals to 1 upon omega C. XC is what we call the capacitive reactance. It is also resistance, but in case of capacitor. In case of capacitor, the value of resistance is XC. And we can use the same formula for inductor also. This will be I into XL. So XL will be equals to 1 upon omega L. XL will be equals to 1 upon omega L. XL will be equals to 1 upon omega L. Oh, sorry. Oh, XL will be equals to omega L. Omega into L. C is the capacitance. Omega is the angular frequency. Omega is angular frequency. L is the inductance. L is inductance. So I can say from now onwards, this XC and XL are also the resistances. But XC is the resistance of capacitor. XL is the resistance of inductor. Like R is the resistance of resistor. Now you have to make the impedance diagram. Guys, in the impedance diagram, you show the same phasor diagram, but in terms of resistance. Instead of VR, you will be writing R, its resistance. Instead of VL, you will be writing XL, its resistance. Instead of VC, you will be writing, I would say, XC, its resistance. So impedance diagram means that diagram in which you show the phasor diagram with the resistances. Okay. Absolutely, sir. In this particular case, let's suppose by any chance, if this XL came out to be greater than XC, inductive reactance came out to be greater than capacitive reactance. Okay. If XL becomes greater than XC, then LCR is inductive in nature. In that case, LCR circuit is inductive in nature. So if this becomes greater than this, then LCR is inductive in nature. So resultant diagram would be in that particular case this that is mentioned. That will be XL minus XC upon this R. And the resultant of this Z, R and XL minus XC is Z. This will be the net resistance. This is Z. And this Z is called net resistance of LCR. And this Z is actually called impedance. This Z is called impedance. Z is called impedance. Okay. Z is the net of XL minus XC and R. So it is called impedance. And if somebody says what will be the value of Z, will be say under root of that is XL minus XC a whole square plus R square. This is how do we find the Z? That is mentioned over here. If somebody says this is at an angle theta, phi, what is the value of phi? Tan phi will be perpendicular by base. Perpendicular is what? XL minus XC divided by base is R. Divided by base is R. Now, if LCR is capacitive in nature, what does that mean? That means XC becomes greater than XL. So this will be the diagram in that particular case. This will be the resultant. So this is R, this is XL minus XC, this is going to be the resultant Z. So I can say Z in this particular case will be under root of XC minus XL whole square plus R square. And my dear NEET aspirants, what I can say in this particular case, tan of phi will come out to be, that is perpendicular by base. Guys, if phi is making the angle, if this phi is with R will be base, XC minus XL will be perpendicular. So it will be XC minus XL divided by base is R. Divided by base is R. Okay. This I have already told you, capacitive reactance and inductive reactance. Okay. Yes. Okay, one more important thing I just want to say over here. Variation of impedance with frequency. Guys, in case of pure resistive circuit, if somebody says what will be the graph between resistance and frequency, no graph. It does not depend upon the frequency. Graph will be constant. In case of pure inductive circuit, what will be the graph between XL and F? Yeah, inductive reactance and frequency. It will be directly proportional. Sir, how? I'll make you understand how. See, we can say XL is equal to omega into L. You can say XL is equal to omega is 2 pi into F into L. What will be the value of XL? XL is proportional to F. It is directly proportional to this. When it comes to XC, you say XC is 1 upon omega C. I'll write over here. We can say XC is 1 upon omega C. So XC will come out to be 1 upon omega is 2 pi F into C. So what is the value of XC? XC is inversely proportional to frequency. So that's why graph is rectangular hyperbola. That's why graph is rectangular hyperbola. And if somebody says what is the graph between this impedance and frequency? Impedance is the net resistance of LCR circuit. It would be something like this. It would be something like this. Here I have explained the clearly. Z is equal to XL minus XC ka whole square plus R square. Z is equal to, this will be considered as omega into L minus 1 upon omega into C whole square plus R square. Omega is 2 pi into F into L. This is 2 pi into F into C whole square plus R square. Now, if you keep frequency 0, this term will become 0. 1 by 0, this will become infinity. So Z will come out to be infinity. So when frequency is 0 here, Z is infinity. It comes from infinity. And when you keep frequency infinity, so this term will become infinity. Okay, so infinity whole square, infinity. So I would say Z will become infinity in that case. See. If frequency is infinity, Z is infinity. So the graph would be something like this. You can directly remember graph between Z and F is this. Resonance condition. A resonance condition of an LCR simply means when The resonance condition is when XL becomes equal to XC. If in an LCR circuit XL and XCL are equal, then it is called a resonance condition. Then it is called a resonance condition. Okay. If XL is equal to XC, this is called a resonance condition. And in case of resonance, we say net resistance impedance Z, that is equal to R. You can say it also. XL minus XC ka whole square. This and this will cancel. So it will become under root of R square. Square and root will cancel. So Z will come out to be equal to R. Z will come out to be equal to R. Okay. Yes. Now one more important thing. When XL is equal to XC, you can write omega L, omega C. Take this omega here. So it will become omega square. Take this L here. It will become 1 upon LC. So omega will be under root of 1 divided by under root of LC. So this is called a resonance angular frequency. This is called resonance angular frequency. Even you can write it like this also. Omega is 2 pi f. So here, instead of this omega, you can write 2 pi f. So 2 pi f is 1 upon under root LC. So from here, frequency will be 1 upon 2 pi under root of LC. This is called a resonance frequency. This is called a resonance frequency. Okay. Yes. Let's suppose you have this question. They ask you to find the resonance angular frequency. That is omega. That is under root of 1 by under root of LC. Put the value of L. L is given. C is given. You can find the value of resonance angular frequency. Transformer. Guys, why do we use transformer at home? Why do we use transformer at home? We say transformer is a device which is used to step up or step down the alternating voltage. Like if this is your home, inside your home you have television. Do you use the television wire directly to plug in the socket? No, sir. You basically keep the transformer in between. If this is a television, you take a wire from it, you connect it to the transformer. And then this transformer is connected to the outer supply. Why? Because if the load, if the supply from the outside is large, we say you give directly to this, it is going to burn the television. What is the maximum voltage that television can take? 220. If you give more than 220, we say it is going to burn that. That's why we use transformer in between. If the supply from the outside is large, it will manage that. It will stabilize that. It will decrease that. Okay. It will decrease that. So my dear NEET aspirants, when the supply coming from the outside enters the transformer, it decreases that supply. It decreases that voltage. It makes it sufficient so that this television works properly. Even if the supply from the outer side comes less, it is going to step up that. So it is going to increase the voltage in that particular case. It will send the sufficient voltage. This is the work of transformer. It is used to step up or step down the alternating voltage. Now guys, see. Transformer is made up of basically a soft iron core. This material is basically called soft iron core. And there are two coils which are wound over here. This is what we call the primary coil. This is what we call the secondary coil. So basically the supply which comes from the outer side enters the primary coil. The supply which leaves the transformer is what we call the secondary coil. That is the secondary current. Now the voltage which comes from outer side, that is V in. That is V in. Listen carefully. I'll show you here. So the supply which comes from the outer side, that is basically V in. Now this supply is basically either the transformer will step up or step down. That depends upon the voltage. It will send the output voltage. So this output voltage will be equals to input voltage into number of turns in secondary coil upon number of turns in primary coil. NS is the number of turns in secondary upon NP is the number of turns in primary. This is the output produced by the transformer. Okay. And my dear NEET aspirants, this is the flux produced. See basically what happens. Basically when the current comes that enters the primary coil, it creates the magnetic field. So when this magnetic field crosses the coil, flux is produced. So this is the flux in the primary coil. Now that flux is transferred to the secondary coil. So this is the flux in the secondary coil. So how much is the flux in secondary coil? 5s. How much is the flux in primary coil? 5p. And my dear NEET aspirants, if I say how much is the output voltage V out, how much is the input voltage V in? Now, let's suppose I give you the question over here. With the help of the question, you will be able to understand. See, the primary winding of a transformer, primary winding, primary coil has number of turns as 500. That is NP. And the secondary winding has number of turns in the secondary coil has 5000 turns. Connected to an AC supply of this. Okay, so input voltage is given as 20 volts. The secondary voltage, so output voltage, how much output voltage the transformer is going to give in this case? You say, sir, when it comes to the output voltage, it is input voltage into number of turns in secondary upon number of turns in primary. Because this is the formula we studied. Input, number of turns in secondary upon number of turns in primary. Now tell me. So this output voltage is going to be number of turns in primary. This is the primary voltage which it receives. Secondary, it is 5000. Primary, it is 500. 0, 0, 0, 0. 5 ones are 5 tens are 10, and this will be 200 volts. So output voltage is going to become 200 volts in this particular case. Okay. So this is how the transformer works. Primary coil basically receives the input current or input voltage, and then it stabilizes that. If that is less, it will increase that. If that is more, it will decrease that. And it will send to the secondary coil as output. This is the output created by this. One more important thing in this particular case, we say efficiency of a transformer. Efficiency. I'll write over here efficiency. Efficiency of the transformer is neta. It is basically output power divided by input power. Okay. If I say, let's suppose for an ideal transformer, we say neta is 100%. Efficiency is 100%. Listen to me very carefully. What does that mean? What does that mean? Sir, output is neta times of input. If I say efficiency is 100%, means 100% of input power. This will be power output. If I say neta is 100%. 100% means 100 by 100. 20% means 20 by 100. 30% means 30 by 100. This and this will cancel. So in this particular case, output power will be input power. So means the amount of power you supply to the transformer, the same amount of power it will give. So means power loss in this case will be how much? 0. That is what we call efficiency. So 100% efficiency is not possible. So this is what we call the efficiency of a transformer. I hope this is crystalline clear. Guys, with this we have finished this chapter also. Okay. Thank you. So I would say electromagnetic waves, we will finish in the next session. Okay. So that's all for today. So thank you so much. Take care and bye-bye. See you guys in the next session, and do let me know in the comments how was the session. Okay. So take care and bye-bye. Thank you so much. See you guys in the next session. Till then, bye-bye and take care.